Back, everyone. We are in section 6 of chapter 1, and here we're dealing with the absolute value. Now, you probably remember the absolute value of whatever's in the absolute value, just make it positive. If it's negative, make it positive. If it's positive, keep it positive. And here's the official definition. We have the absolute value of x is equal to x if x is positive, bigger than or equal to 0. And absolute value of x is equal to negative x if x is negative or less than 0. So basically, if it's negative, slap another negative onto it, multiply it to change it positive. And here lies the issue that we're going to run into. Notice that I have two different numbers in the absolute value, and I get the same answer for both. So what we're going to have to do when we are solving equations that have absolute values in them is we're going to have to take on both the positive part and the negative part using the definition here. So in general, first you want to isolate the absolute value expression, write the positive and negative equations of each. We did here. We'll see examples of that in a second. And then check for extraneous solutions. Remember, extraneous solutions are answers that that when you plug it back in, it actually doesn't work. And that does happen with absolute values sometimes. Absolute values must be non-negative, meaning if you come across exactly the absolute value of x equals -5, you're done. There's no solution here. Example 1. All right. So if you remember, one of the first things is you have to isolate the absolute value, meaning get the absolute value by itself first. And you'll notice I have a -4 here. So for part A, actually what I need to do is add that 4 to both sides. So that we're there. So now the absolute value is isolated, it's by itself. And now I'm going to have the positive version of this. Or the negative version of this. And now I have two equations to solve. Now I want to make it clear on a test or something, when you if you just do this and you don't do the other part, if I'm your teacher, you don't get any credit for that at all. The whole point of this is that you understand that there are two potential solutions here. I'm going to subtract the 4 to both sides and divide by -3. Distribute the -1. Add the 4. Divide the 3. And actually, when we check both of these both do work. So we have two solutions in this case. Part B is a little more complicated. So I have the absolute value by itself. So I have x plus 1 equals x squared minus 5. I also have negative x plus 1 equals x squared minus 5. I'll deal with this one here in just a minute. I'm going to subtract the x and subtract the 1 to this side over here. So we get x squared minus x minus 6 equals 0. And this factors. So we get x equals 3 and -2 in this case. Actually, both of these work. If you're not sure, you can always plug them in, see what you get. Here I have negative x minus 1 equals x squared minus 5. Adding those to the other side, I get x squared plus x minus 4 equals 0. So we now have a quadratic that does not factor. So we're going to have to use the quadratic equation. Start way over here. -1. So A is 1, B is 1, C is -4. So the square root of 1 squared minus 4 times 1 times -4 all over 2 times 1. So that's 1 plus 16 over 2. That's -1 plus or minus root 17 over 2. So we have two irrational solutions. So we have actually 4 answers in this case. 3, -2, -1 plus root 17 over 2, -1 minus root 17 over 2. All right, so those are equations. What if we have inequalities? Well, you can imagine when we have the negative side of it, remember when we multiply or divide by negative that the inequality switches. So this gets a little tricky. If it's a less than case, then it turns into an and statement. We actually can write it like this. This is going to actually be a little bit easier to work with. And for the less than ones, I am going to do that, where whatever that is, the negative version of it goes on the left, whatever's in the absolute value goes in the middle, and then the positive version goes on the right. Now, if it's greater than, we can't do that. We have to break it up into the greater than or the negative greater than, and have to deal with it. And you can see when we're divided by a -1 or something that's going to switch the inequality and things like that. So let's go ahead and do this. All right, let's do part A. Again, we want to get the absolute value by itself, right there. And so I'm going to add that 5 to the other side. 2 minus 6x is less than 6. And so I'm going to use this trick here. This is because it's less than. So -6 is less than 2 minus 6x is less than 6. Subtract a 2. So we have -8 less than -6x less than 4. And now I'm going to divide, be careful, by a -6. So this becomes 4/3 is greater than now. X is greater than -2/3. And if we write this in interval notation, this is -2/3, comma 4/3. All right, part B. Part B is, actually, I'm going to divide both sides by -1. That'll change the inequality. So this just becomes absolute value of 3x minus 3 is now less than or equal to +8. So I divided both sides by -1 here. And you can see this is still a less than case. So we can do that. I'm going to add a 3. Goes to 11, and then divide through by 3. It's a +3, so the signs don't change. So this becomes -5/3. That's a bracket. And 11/3 bracket. All right. Part C. I'm going to go ahead and add that 3 to the other side. Now we're to the second case here, where we can't do our little negative and positive trick. So this becomes 2x plus 5 bigger than or equal to 7, or -2x plus 5 is bigger than or equal to 7. It's not always taught this way. They often just say rewrite it, switch that, and switch the sign. But that's because we're dividing by the -1. So I'm kind of showing you where that comes from. I'm going to subtract the 5, divide by 2. This one I'm going to distribute the negative. I'm going to add the 5 now. And divide by the -2. And of course, that'll switch the direction of the inequality. So this actually is going to be -infinity to -6 inclusive, union with, including 1 off to infinity. So whenever it's less than, there's not going to be infinities involved. Whenever it's greater than, we're going to end up with the union and the negative infinity and positive infinity and all that sort of stuff. For part E, which will be D on yours, when I subtract that 3 to the other side, so what we're calling E, but will be D on yours, and I'm here, this is now bigger than -2. This goes to this last part. Absolute values are always positive. So it's always going to be true. It's always going to be bigger than a negative, any negative, but in this case, -2. So the answer is going to be negative infinity to infinity. I don't have to do any work. I don't have to do any tricks or anything like that. Now, if it was a less than, then there would never be a solution because you can't have an absolute value less than a negative. It just can't happen. I hope that helps.